All right, hi kiddos, how you doing? It's good to see all of you. I miss you guys so much, and most importantly, I miss all of our science labs. So today is going to be our first attempt at a virtual science lab. So what's going to happen is I'm going to walk you through the lab, I'm going to show you how the lab's done, and then you guys are going to be responsible for filling out the lab sheet. Now I want to tell you that the lab sheet can be found in a Google Doc that you'll have to type in the correct answers on Google Classroom. I believe the document is called Lava Lab. So you'll want to locate that either during the video or right after the video to collect some of the data, also to make your hypothesis and to draw your conclusions. Remember, I always expect PQPA on those lab packets, so make sure we're doing PQPA, okay? So let's first start with talking about lava. I'm sure all of you know by now. If you don't, we really have to work on that because we have been talking about this for a long time, but what is the difference between lava and magma? Well, to remind you what the difference is, lava is going to be above ground, whereas magma is going to be below ground. Okay, I made a little cheat sheet for you guys. So lava is found on top of Earth's surface, whereas magma is still inside underground in that volcano. They are both molten rock, which means it's in a liquid format. Okay? Now, we're going to talk a lot about viscosity in today's lab. You probably haven't heard of viscosity before, but all liquids have an element of viscosity. And what viscosity is it's the ability to resist flow, okay? It talks about how fast or how slow a liquid will flow down, okay? Now, a high viscosity means it's got a high ability to resist flow, which means it's going to have a low speed, okay? So I need you to remember that. High viscosity actually means a low speed. And low viscosity actually means high speed because it has less resistance to flow, which means it's going to flow faster. So hopefully that makes sense, and we will revisit this as we complete the lab together today. Now, you also will need to make sure you have located your data table on that Google document. You will be expected to fill out the data table. I have mine in a whiteboard here for you guys so you can see what I'm doing and filling it out. I will do the first one, speed and viscosity, with you guys so you know what you're doing calculation-wise. Once you've already done that, then you guys will be responsible for figuring out these last two on your own. Okay, so just keep that in mind as you watch throughout. Let me tell you what our lava is going to be today. Our lava is going to be a mixture or a combination of distilled vinegar, nice, and baking soda. Okay, so here's our lab materials. We are going to let our we're going to let our lava flow in this nice brownie pan. The first thing we need to do is we need to make our hypothesis on which different lavas we think are going to flow fastest or slowest or have a high viscosity or a low viscosity. So go ahead and make sure you have done your hypothesis now. All right, I can't speak today. If you have your hypothesis done, now we're ready to move on to the procedure. There are three types of lavas we are going to test today. We are going to test basalt, andesitic, and rhyolic, okay? Something you need to know about each of these three different types of lava. Rhyolic has a high viscosity, and that's going to come into play later when we're trying to figure out which lava is which. Andesitic is going to have a medium viscosity, and basaltic is going to have a low viscosity, okay? So keep that in mind. We'll revisit that as we work through the lab. The first thing we need to do in today's procedure is we need to measure in centimeters how long our pan is, or the length at which the lava is going to flow. Now I'm going to put this little cup kind of a little bit down off of the pan because it won't stay up at the very top for me. So I'm going to measure from where the cup starts till the end of the pan to make sure that I'm being super accurate. I'm going to use the yellow side because I want centimeters, always in the metric system. And I'm going to measure the pan, which is roughly 25 centimeters, okay? So what you'll need to do on the data table, where it says length, you will need to put 25 centimeters all the way down, because we're going to use this same pan for each type of lava test. Just like mine, 25 all the way down, cm for centimeter. Awesome, don't forget to label. Okay. Next, we are ready to measure out our baking soda. Now, our baking soda is not going to change at all during the lab. We are going to use a half teaspoon of baking soda throughout the entire time. So this is not going to change. So I'm going to go ahead, I'm going to measure out a half of a teaspoon of baking soda, and then I'm going to put it in my cup. I got my, and it's in my measuring cup. All right, now I'm ready. The independent variable of this lab, or the thing that we're going to deliberately change, is the amount of vinegar, okay? The amount of vinegar we're putting into our lava to see it flow, okay? All right, so we have measured out our half teaspoon of baking soda, and now we are ready to measure out how much vinegar we need. For lava number 1, we are going to use 10 milliliters of distilled vinegar. So I'm going to very carefully measure out, using my graduated cylinder, 10 milliliters of vinegar. Oops, and I overdid it. So now I need to just pour a little back. And I'm a little shy. Remember, you want to be as accurate as you can possibly be when measuring out anything in a science lab. Okay, still a little heavy. And remember, you can't test it up here like this because your hand will shake and you don't know if you're holding it level. So you need to place it on your table, and you need to get down at eye level to make sure it's exactly where you want it to be, which in our case it is. So 10 milliliters first. Now I'm going to pour the vinegar into the cup, and you are going to watch as the baking soda and vinegar interact with each other. It will slowly flow over and flow to the end, okay? But we have to time it so that we can figure out its viscosity and its speed. So I'm going to use my cell phone here as my timer. We're going to time it in seconds. And so right as I pour, I'm going to make sure I hit the start so that I'm ready to time. So I'm going to put my finger right over the start button, and I'm going to pour. Are we ready? And 3, 2, 1. All right, flow, 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 flow. And stop. All right, I wait till it gets down to the very end. So this one lasted 8.71 seconds until it reached the bottom of the pan. So this was lava number 1. We're going to revisit our data table. Under time, on lava 1, we're going to put 8.71, and it's seconds, so SEC. Whoop, there you go. All right, make sure you're filling out your data table with me. All right, that was a success. That was lava number 1. All right, now I'm going to need to dump and restart for my next one. So I'm just going to go ahead and dump it at the edge of the pan because I don't really have to do anything with it. There's not much there. Again, remember, the amount of baking soda we have doesn't change. So I'm going to go ahead and I'm going to measure out a half teaspoon of baking soda again and dump it in my cup. I am going to switch out my cup here. I'm going to use a clean cup that doesn't have any baking soda or vinegar in it. All right, dump, half teaspoon. Going to put there. Do I have to measure the pan again? No, because it's the same length, same pan. I'm not changing anything other than the amount of vinegar I'm going to put in. Now, last time we did 10 milliliters. This time we're going to do 20. So I've got to measure out 20 milliliters very carefully of vinegar. Ooh, okay, I'm a little bit heavy. Just got to pour a little bit back. Ooh, just a teensy bit. Perfect. All right. Again, I have to time it, so I need to reset my timer, and I need to get ready to pour. Again, I'm going to dump the 20 milliliters of vinegar, and it's going to see how long it's going to take to hit the bottom of the pan. Now, we're adding more vinegar, so what might that tell you about, if you're predicting right now, what do you think it's going to do if we add more vinegar? Do you think it'll flow faster? Do you think it'll flow slower? I don't know. Let's see. So, we're going to go ahead and dump. I'm going to count down again. 3, 2, 1, and go. All right. Woo, that was much faster. Had more of a reaction there too. So this time I got 3.05 seconds. We are going to record on our data table 3.05. Again, it is SEC for seconds. All right, don't forget to fill out your data table with me. All right. Finally, last one. Dump it all out. Make sure there's nothing left in there. I am going to go ahead and wipe out the cup. I only have 2 different cups. So I'm going to wipe out the cup so that I'm ready for my next experiment. Get my paper towel. I'm cleaning out my cup, making sure there's no vinegar left in it. All right, I'm putting my cup back at the top. And this time I'm going to use the same amount of baking soda, a half teaspoon. That doesn't change. And dump. All right. And then this time I'm going to use 30 milliliters of vinegar. Now, we know that the first one was 10 and it flowed pretty fast, but still kind of slow. And then the second one flew even faster when we did 20 milliliters. So using your hypotheses and your educated guesses, think about what would happen now that we're going to add 30 milliliters instead of 10 or 20. Most likely it will increase the speed of the lava, which means it's going to have the lowest viscosity yet. All right, very carefully. Ooh, a little bit more. Ooh, a little too heavy. And pour a little back. And a little bit more. All right, perfect. I'm going to set it down just to make sure I'm right. Yep, very good. Remember, you cannot measure accurately up here. You got to set it down, not touching it, get down to eye level to make sure that it's right. All right, looks good. I'm going to reset my timer, and I'm going to count down again. We're going in 3, 2, and 1. All right, this one was the fastest one yet. This one actually dumped over too, if you can see. We got quite the mess going on. This one was 2.04 seconds. So, taking my marker, going to my data table, 2.04. And it is in seconds, like so. All right, now we have all the data we need collected. The part of our lab component is done with. All right, so now I'm going to teach you how to calculate your speed and then figure out the viscosity of each different type of lava. I'm going to do lava number 1 with you here on this video, and you guys will be responsible for doing lava 2 and 3 on your own. So I wanted to remind you, I know we've calculated it quite a bit in class, but speed is length divided by time. For lava number 1, the length was 25 centimeters, which will be the same for all of them, and the time was 8.71 seconds. So what you're going to do is you're going to take 25 and you're going to divide it by 8.71. And that answer is your speed. So in this case, our speed is 2.87. You can go ahead and round to the nearest 2 decimals. So speed for lava number 1 equals 2.87 centimeters per seconds. Okay, and I'm going to go ahead and highlight this because this is your answer. Okay, so that is how you find your speed, which should be a quick review. Now, once you have your speed, then you have to decide, is it a high, medium, or low viscosity? I wanted to remind you up here that a high speed is a low viscosity. A low speed is a high viscosity. Now, it's going to be really hard to figure out which is a high, medium, or low until you have calculated your other 2. But based on what we saw in the lab, we know that the first one flowed the slowest, which means it's actually going to have the highest viscosity. So I'm going to go ahead and help you with that one here. So viscosity for lava number 1 equals high, and we'll just leave it at that. And I'll go ahead and highlight that for you. And there are your 2 main answers that you need to add to your data table. Now, I just want to remind you, the independent variable, or the thing that we purposely changed in this lab, was our amount of vinegar. The dependent variable, what changed in effect of that, is how fast the lava flowed, or its speed. And then in turn, we got to figure out its viscosity. Now, what you're going to do is you're going to calculate for lava number 2 and 3, and then you're going to determine which lava, 1, 2, or 3, is rhyolic lava, which lava is basaltic lava, and which one is andesitic lava. All right, kiddos, good luck. Thanks, and I'll see you next time.